Oh my gosh, crossed fields, okay. So in a mass spectrometer, electric and magnetic fields are used to select charged particles of one particular speed. A uniform magnetic field is applied to the region between the plates. They're talking about these plates right there. Such that the electron now passes between the plates without being deviated. That is, it no longer deflects itself 3/4 of a centimeter upward, right? It's just going to go straight. This guy's going to go, right? Okay. So state and explain the direction. Okay, we can do this. Okay, so remember that this is a negative charge, right? It's a negative charge. It's going to be attracted to the top plate here, right? That's because this is positive 95 volts, right? So the electric force is going to be this way. Okay, to counteract an upward electric force, we have to have a downward magnetic force. Okay, is that one of the marks? Maybe it is, right? So electric force is upward, so therefore we need a downward force, right? Okay. And then now we got to figure out the cross product here. So here's our velocity here, right? It's funny, I can sort of color this in. So here's our velocity. So put your index finger that way, right? Okay. So here this thing is, right? This is going to be your index finger of your right hand. Okay. Put the thumb this way. Okay, thumb that way. Okay, so I got my index finger, I got my thumb there, right? Okay, now my middle finger is right now as I'm doing this. You can't see me doing this, right? But you know I am. Okay, my middle finger right now is out of the page. Okay, but remember that this is a negative charge, so the actual direction of the magnetic field is into this page. Okay, so explain that, right? So do a here's this thing, right? A negative charge, the velocity is this way, magnetic force is this way. This is our thumb. This is our index finger, right? Middle finger is negative out of the page, right? Which is into the page, okay? So the magnetic field will be into the page, right? Determine its magnitude. Okay, we can do this. This is actually pretty simple, right? So if you look at our formulas for, whoa, I just lost everything here. If you look at our formulas, I'm going to use formula 5-4, number 1, which is force is QVB. This is section 5-4 of your data packet, QVB sine theta. But theta is 90 degrees, so it's just QVB, right? Okay. And then I'm going to use equation 5-1, the fifth equation. Section 5-1, the fifth equation is E is F over Q. So therefore F is EQ, right? And then we're going to equate these things, right? So the electric field times Q is equal to Q VB. So as long as Q is not 0, we can divide by it, right? Okay, and we know the velocity, right? Here's our velocity. So that's going to go, plug it in there, right? We're trying to find the magnetic field. The electric field, we actually figured out the electric field in part C, letter 2I. So CII, look in there. We figured out the electric field is, what, 95 over 0.022, right? 95 volts changing over 2.2 centimeters, right? Okay, it was 4318.18 bar, right? So plug that in for our electric field, and you will get a pretty small number, okay? It's on the order of 10 to the minus 4th Teslas, okay, for B. Da-da-da.